Good morning. We're going to learn something today that is one of the most commonly referenced math topics in pop culture. So like in movies, TV shows, stuff like that. If there's like a show or a TV show or a movie about school and there's some scene in a math class, most likely they're talking about the Pythagorean Theorem. It's almost a cliche at this point that this is where TV and movies go when it comes to math. So everybody, we're going to sound this out because it's kind of a tough word. Everybody repeat after me. Pythagorean Theorem. Pythagorean Theorem. Beautiful. That's not too bad, right?
Yeah.
It's not Pythagorean, even though technically it is spelled kind of like that. It's pronounced Pythagorean Theorem. All right? And the Pythagorean Theorem states that a squared plus b squared is equal to c squared. All right, so A and B, make sure you highlight in one color, C in a different color. So Aaron, go ahead and take your notebook out. Because A and B are going to represent our legs, like we talked about yesterday. And C is going to represent our hypotenuse. What is the hypotenuse? Does anyone remember from what we talked about yesterday what that is? Exactly, the longest side of a triangle. Great job. So the two shorter sides, we're going to square them, add them, and then take the square root. Exactly like we did with the distance formula, because they're the same thing. So we're going to use triangle ABC from note sheet 11. So the one we got yesterday, take a look at triangle ABC. I'm going to try and see if I can fit it. There it is. Here's triangle ABC. What is A equal to on this triangle? A is equal to 5. Is that what it says on the triangle? A is equal to 3. What's it? Yeah. Here you go. A is equal to 3. So 3 squared. What is B equal to? 4. My side B is 4 units long. I'm going to plug that in for B. And what is my hypotenuse equal to? 5. C is equal to 5. Come on. Thank you. And then So we plugged in A, B, and C. We just plugged in for A, B, and C. Now, not every triangle we look at is going to be A, B, C. We just have to remember that A and B represent the legs, and C represents the hypotenuse, right? So the longest side is on its own. On the right-hand side, both my legs over here on the left. Now we just solved this. What is 3 squared equal to? 9. What is 4 squared equal to? 16. What is 5 squared equal to? 25. Now we're going to add 9 plus 16. What do we get when we add 9 plus 16? We get 25. And on the right side of my equal sign, I get 25. Is 25 equal to 25? Yeah. This is a true statement. All right. Our formula worked. This is a right triangle. So there's going to be a part of this unit, not necessarily today, but we'll build up to it next week, where you're going to be given 3 side lengths, like 3, 4, 5, 6, 7, 8, 10, 12, 15. And you're going to have to determine, do these 3 side lengths form a right triangle. All you have to do is plug them in, work it out, and see if your statement's true or false. But we'll get to that. What we're going to do with this formula today is find the missing side length of a triangle. Find the missing side length of a triangle. So let's take a look at this triangle ABC. We've got a missing side length, my question mark here. We're going to figure out what that side length is by using the Pythagorean theorem. So think back to what we talked about yesterday when we reviewed triangles. All right, I've got angle A up here, angle B down here, angle C over here. What is side A equal to? Anyone got an idea of what side A is equal to? 12? Exactly right. Why do you say 12? How do you know that this is side A? Say that one more time. On the other one, which other one? What are you talking about? The first triangle, this one here? Ah, side A is in between points B and C. That's great. Exactly. And also, angle A is directly across from side A. That was part of the triangle review we talked about. Great job. Down here at the bottom, we said the uppercase letter of each angle opens up to the side with the same lowercase letter. Angle A opens up to side A. So if I'm looking at my new triangle, here's angle A. I look directly across from that angle to give me my side A. All right? What is side B equal to? Well, here's angle B. We look directly across from that angle. And what is side B equal to? 5. So we know that A is equal to 12, B is equal to 5. What is C equal to? We don't know. It's exactly what we need to find out. What is the length of C? Which of these letters, A, B, or C, is my hypotenuse? C. How can we tell? If we don't know how long it is, how do we know it's the longest side? Because it looks like the longest side? Yeah, but we can't know for sure. What did we talk about yesterday? Take a look at note sheet 11. See if you can find the answer to that question. How do we know side C is the longest side if we don't know how long it is? Yeah, Darius? Oh, I thought you had your hand up. My bad.
The right.
Say that one more time, Darius.
The right angle of a right triangle is always across from the
Hypotenuse.
hypotenuse.
Exactly. Take a look. The right angle of a right triangle is always across from the hypotenuse. We didn't talk about triangles yesterday just to waste time. We talked about it to get us ready for today. We don't know that this question mark is larger than 12 or larger than 5. But we do know that the right angle here, see this little square, we do know that this right angle is pointing at my hypotenuse always. So wherever you see the right angle, it's pointing right towards the hypotenuse. Right? If I didn't have letters A, B, and C here, I just had 5, 12 question mark and that right angle square, we'd have to assume that this is the hypotenuse because it's across from the right angle. We have to understand that if we want to be able to do any of the problems on the worksheet. Because on the worksheet, we don't get letters. We just get something like that. All right? You got to know how to find the hypotenuse, which side is the hypotenuse, based on your right angle. All right? So we know that A is equal to 12, B is equal to 5. I want to find C. We're going to set up a nice simple equation here. A squared plus B squared equals C squared. My A, we said, was equal to 12. I'm going to plug that in right there. What was my B equal to here? 5. I'm going to plug that in right there. And again, we don't know what C is, so we're going to just leave it as C squared. Hopefully you see that this looks just like our distance formula. D squared equals both my numbers squared and added. Plugged inside A, inside B. We're going to find what side C is equal to. And I forgot to take out the answer, but that's okay. What is 12 squared? 144. What is 5 squared? 25. We squared 12 and 5. Boom. We're going to add them. What is 144 plus 25? 169. Boom. Square them, add them, take the square root. It's the same process as before. If I take the square root of 169 and the square root of C squared, the square root of C squared just comes out to C. And what is the square root of 169? 13. It's a perfect square. We should know that. That's why we did the book it yesterday. C is equal to 13. Could say units, doesn't really matter to me personally. But we see now that C is equal to 13. So if we look back at our right triangle properties, right? The hypotenuse has to be the longest side, but it can't be longer than A plus B. So 13, is that the longest side out of these three measurements? Yeah, 5, 12, and 13. 13 is the longest. What would A plus B equal? 17. 12 plus 5 is 17. Is that greater than or less than 13? Greater than. So this works out perfectly. All right, our hypotenuse has to be the longest, but it can't be longer than A plus B, the combined length of our legs. So when it comes to what work we're going to be doing today, this is the work right here. You take your legs, plug them in for A and B, square them, add them, take the square root, you've got your distance. It's exactly the same as what we did yesterday, and even what we did on Tuesday. Was that Tuesday? Wednesday. These 4-day weeks are weird. So this is nice because we had a perfect square. We get a nice even 13. But as you can probably assume, it's not always going to turn out that way. Let's see what we can do with this triangle. Go ahead and flip over or right next to wherever you've got some room. Go ahead and draw yourself a little triangle like that. It doesn't have to be perfect. Go ahead and draw yourself a little triangle just like that.
There we go.
With a height of 3, base of 9. All right. So we're going to take our formula. A squared plus B squared equals C squared, our Pythagorean theorem. What are we going to plug in where? 9 is A, 3 is B. That works for me. In reality, it doesn't matter which one's A or B. How do you know that these are both the legs and neither one is the hypotenuse, though? Yes, that's true in our equation, but how do we know that this side here is C? Yeah, what tells us, Karina? Exactly. Here's my right angle. We could think of this right angle like an arrow that's pointing directly to my side C. Again, you're not going to get letters, all right? But you have to know the right angle points to my side C, right? The legs of this triangle open up to that side C. Okay, and the right angle is right in between both of our legs. You know what I mean. So C's on this side. We're going to plug in, we said, what was A? 3? It doesn't matter. 3 is A, 9 is B. I always like to just go smallest to largest, but it doesn't matter because you're going to square them and add them. What is 3 squared? 9. What is 9 squared? 81. Okay, we squared them. Bless you. Now we're going to add them. What is 9 plus 81? 90. Yeah, 9 plus 81 is 90. That's okay. Now what are we going to do to get C all by itself? Square root the left, square root the right. Is 90 a perfect square? Nope. Let's break it down. What two numbers multiply to give me 90? 9 and 10.
We could bring down 5, right?
Well,
10,
yeah, how can we break down 10, Darius?
5 and 2.
Perfect. How can we break down 9? 3 and 3. So I've got a 3, a 3, a 5, and a 2. All right, square root of 3 times 3 times 5 times 2. And this is equal to just C. Now the square root of C squared is just C. Is there any pairs here I can take out?
3.
Pair of 3s. What's left behind?
5 and 2.
5 and 2. What do we do with that 5 and the 2? We multiply them together. So I've got a 3 on the outside. What's on the inside of my square root now? 10. And this is equal to C. All right? It's not pretty. It's not as nice as 13. But that is our distance. That is our length of C. C is equal to 3 root 10. One of my legs is 3 units long. One of my legs is 9 units long. My hypotenuse is 3 root 10. And we can confirm that this is the longest side by estimating, right? We know that the square root of 90 is close to 81, close to 100. So it's in between 9 and 10, right? Let's say it's 9.5. If we said this side was 9.5, is that the longest side of this triangle?
No. Yes.
Yeah, 9.5 is larger than 9, and it's larger than 3. If we add the legs together, what do we get? 12. Is that longer than 9.5? Yeah. So that all works out. That's not something you have to do. It's just something I'm explaining. Right? So the square root of 90, yeah, in between 81 and 100, so it's like 9.5. You don't have to worry about estimating and doing the decimals. I'm just saying for, explanation's sake. That's what we get. Let's do one more. We got one where everything comes out of the square root evenly. We did one where part of it comes out, part of it stays behind. Let's do one like this. That is not a triangle, but it's okay. Thank you. It kind of looks like pizza. It's a triangle. Pizza is a triangle, right? Well, pizza's not really a triangle because the crust is rounded, but it's a triangle enough.
If you have thin crust.
It's still round.
Okay.
Pizza's round, right?
Yeah.
Unless you have a square pizza, but that would be a flatbread, wouldn't it? I don't know. I'm not. Do I look like I make pizza? No. So is that 7 and 8 or 7 and 6? What was I supposed to do? Oh yeah, 7 and 6. So here we go, 7 and 6. Again, I'm going to use a squared plus b squared equals c squared. What am I going to plug in where? 7 and 6. Well, what am I plugging 7 and 6 into? A and b. How do we know that neither one of those is my c? The right angle. This is what we're looking at. See this right angle here? Right? If we draw an arrow using that right angle, we're pointing at the hypotenuse. Now, this isn't as important to know today because all of your hypotenuses are going to be missing. But once we move on next week to when a leg is missing, you really need to know which one is C. Doesn't matter if 7 is A and 6 is B, or if 6 is A and 7 is B. The legs are just the legs. The side C is the important one. So I'm going to plug in 7 and 6 for A and B. I'm looking for C. I'm going to square them, add them, take the square root. Square them, add them, take the square root. What's 7 squared? 49. What's 6 squared? Perfect. We're almost done. Stay with me here. What is 49 plus 36? 85. What do I do now? Square root. The left and the right. The left side, or sorry, the right side just simplifies to C. And 85, we're going to have to do a little factor tree for. What two numbers multiply to give me 85? 5 and 17. Nice. Can I split up 17?
No.
Can I split up 5? No. Can't take anything out of the square root. 17 and 5 don't make a matching pair, so they both have to stay behind. My answer is just the square root of 85. When you really start to think about it and get comfortable with this, you'll start realizing that all of these lessons we've been learning are the same exact thing. Okay, and if you don't see that, work harder. I don't know. You'll see it eventually. It just takes practice, and we're going to get a whole lot of practice today. Any questions I could answer on that? Anyone confused as to why we didn't do anything with this 85? Okay.